Hello guys, welcome back to the new video. So today's Leetcode daily question is maximum ascending subarray sum. So yeah, this question is marked as easy and it is a very easy question. You don't have to think much about the logic part. It will be a very easy. So let me explain you the question. So let's see first read the question. What question is saying? So we have given an array of positive integers which are nums. Okay, then what we have to do, return the maximum possible sum of an ascending subarray in nums. So we have given and positive integer nums, and we have to find the maximum possible sum of ascending subarrays. So subarray, what I think everybody know what is the subarray. Subarray is defined as the contiguous sequence of numbers in an array. Understood? Okay. Now, let's say a subarray, let's say this is our subarray, is ascending. If for all I, okay, where I is from left to right, then the left number is less than right. Yeah, means here they have given what do you mean by the subarray. Note that a subarray of size 1 is ascending, and the subarray of size 1 is also called as ascending. So let me tell you what this mean. If we have uh, array of length 1 2 3, and now if we are finding the subarray, then subarray is 1 1 2 1 2 3, then 2 2 3 and 3. So this is the subarray of length 1. Okay, so the subarray of length 1 is also in ascending order. Understood? Okay, easy. Now, our first approach is a brute force approach. So, what we can do here is first thing is that find all the subarray of the array. Now, traverse all the subarray, check whether it is in ascending subarray or not. So, if it is ascending subarray, then find the sum, and we are also keep tracking of the sum to find the maximum sum for all the subarray possible of the array at the end. So let's say for our given example 10 20 35 10 15 10 20 35 10 50. So this is my example. Now let me give the index for each element. Okay, so now what is our brute force approach? Brute force approach, if you have remembered that I for the yesterday's Leetcode question we did the same thing here. We write the same logic as it is. If you don't know how to write this code, then just go back and watch my previous video. So let me find. So these are, let's say, some my subarray. So first I found this. So what I'll do, I'll take I here, J here, and one loop is for I, second loop is for J, and third loop is for I to J. Now I'm checking if for I to J my array is ascending array, subarray. Yeah, so if for I to J my array is ascending subarray, then I'll do the sum of till I to j. Okay, from I to j, I'll do the sum of all the elements of that subarray, and I'll keep track of the maximum. So for here, let's say my I starting from here, and starting at the start, j will be also from here. Now, what I'll check whether the I to j is ascending. Yeah, so I to j is ascending. So I'll keep the track of sum, which is 10, and there is a one more which is a max sum is initialized to mean. Well, understood? Now I'll moving my j here. Now I'll check if I to j is ascending. Yeah, so what I'll do, I'll find the sum of this array, which is 30. 30 is maximum 10, so I'll update with 30. It was before 10, then update with 30. Now I'll increase check while sum is getting 60. Now checking 60 is greater than 30. Yes, 60 is greater than 30. So what I'll do, I'll update my mix with 60. Okay, now I'll go to J. I'll check whether this is ascending subarray. No, it is not. If from here this point, if we are not finding the ascending subarray, then it will be not possible that for the further indexes of J we are finding the ascending subarray. Okay, so now we are moving our I from here, and again J will come back to here. Understood? Now we will start from I here and J here. Okay, now we will check. Our sum is here 20. So is the 20 is greater than maximum sum? No. So we will keep as it is. Now we are moving J to here. So now we are getting 50. Does 50 is greater than 60? No. Now J here. 5 is greater than. So if we are adding, so first check, this is the ascending subarray. No, this is not ascending subarray. So what we will do, we will reset our indexes and we will increment I to here, and J will be starting from I only. Now we are checking 30 is ascending subarray. Yes. So now our sum is 30, but it is greater than maximum sum. No. So we are not doing anything. Now J here. Is this ascending subarray? No. So what we will do? We will updating our indexing. Start I from here and J will also from here. Is it ascending? Yeah. So we'll update our sum. Now is it greater than maximum? No. Okay, increment J. Is it ascending? Yeah, we are updating our sum. Is it greater than maximum? No. Okay, now here. Is it ascending subsequent sub? Yeah, sub array. Yeah. What is the sum? 65. Is it greater than maximum sum? Yes. So we are changing our maximum to 65. Now J here. J is got out of bound. So at the end we are returning 65, and 65 is our answer, as you can see here also. The same thing is applied for these two cases also. So I am giving you homework to do the dry run for these two cases at yourself. So let me write the approach which is brute force. Here we are, this is here I am telling you the brute force solution. So what we have to do, we require the first loop for I, second loop for J, third loop, or we can say function to check if our sub array from I to J is in ascending order. Yes, if is it so? If yeah, if it's in ascending order, if yes, then find sum and update maximum. Else okay, we can also do this thing. Else break means the next loop will be there. So what is the worst case time complexity for this? So this will take order of n, this will also run order of n, and this checking will be done in order of n. So the time complexity can be order of n cube. So for this question, you can see from the constraints you are able to pass your code with this time complexity also. But let me give you the optimized approach. Yeah, so today I'll give you the optimized approach for the same question. 10, 20, 35, 10, 50. So what is the optimized approach? So let's see what we will do here. This is my optimal. Hmm. We will take a two pointer, yeah, because we want to check that our previous element is greater than the current or not. So the previous element is less than the current or not. So I'll keep track the length. Yeah, length is not that much required. Still, I'll keep track the sum I'll keep track the max sum. Now what I'll do here is I'll first check if the length of the array is 1, then I'll return in the element as it is. Okay, otherwise I'll give I to the 0th index and j to the I plus 1 means first index. Now sum initialized with nums of I, which is 10, and maxsum is initialized with mean value. Okay, now let's do the traversal part. My I is here, j is here. Now what I'll do, I'll just go to j checking. J is greater than I. Yes, the element at index j is greater than element at index I. It means this is the increasing subsequence. Okay, so I'll increase the length. I'll do the sum plus j nums of j. So I'll my sum become 30. Now I'll check if mean value and 30 which is greater than 30. So I'll by 30. Mm. Now I'll increment my j here. I'm checking and I here. The j is greater than I, yeah. So I'll add to here, I'll increment by 3. I'll do the 60 and 60 is greater than 30. So I'll update my max by 60. Now increment I, increment j. Okay, I'll check j is greater than I, no. So now what I'll do, I'll make length to 1. Now my sum is updated by the value at jth index. Understood? I'll again move I to here, j to here. Now again checking that j is greater than I. Yeah. So I'll adding to the value here, increasing length, checking 50 is greater than 60. No. I'll go here, I here. Checking j is greater than I. Yes. I'll add the value here. It will become 65. Length will be 3. And now I'm checking that sum is greater than make sum. Yes. So I'll increment make sum by the current sum value. And at the end, again increment I here, j here. So j is out of bound. So I'll returning the maximum, which is our answer, is 65. So what we are doing here in a single traverse, we are checking that if my current is greater than the previous, then it will be increasing subsequence, and if it's increasing, then just add the current value and compare it with the overall global maximum. Understood? Okay, so here if we are talking about the time complexity will be order of n. So let me directly show you the code. Okay, so this is the code given. So this is first finding the length of the array. Now this is our test case if we have only one element in our nums. If we have only one element in our nums, then we are directly returning that element. Now if we have more than one element, then our I is starting from 0 and j is I plus 1 means the next element, and our initial sum will be of I. Nums of I is the in starting, length is 1, and this is our result means the overall maximum subarray sum, which is initialized with minimum value. Okay, now what we will do, while j is less than n, yeah, will till j will not become out of bound. If our next index means jth value is greater than ith value, then we are incrementing the length, and we are also adding the element at jth index into the sum. Otherwise, we are resetting our length to 1 and compare the current sum to the overall global sum. Okay, so this part is done here, and we are changing our sum to the value which is at jth index. Now we are incrementing I, we are incrementing j till our j will not become out of bound at the end. For the last test case, this is like we have 60 and our maximum is also a 60, but our j become out of bounds, so we didn't get a chance to change this 60 to 65. So that's why we have to do last one more time, and at the end we are returning this result. So if you saw here, we are requiring only one loop to traverse our array. So our time complexity will be order of n. So yeah, this is very easy question for today's lit code. Thank you guys.